everyone, and welcome back to my online teaching platform. In this video, we'll be looking at the various rules of differentiation. So we have done differentiation from the first principle. So we'll be looking at other rules that we can use to differentiate any given function. So we start with the first rule, which is the power rule. So the first rule here is the power rule. All right. So here we'll be considering the rule in terms of power of a given expression in a given function. So if you have a function, let's assume that you have a function to be y is equal to ax having a power of n, where a is a constant, where is where a is a constant and the a is not equal to 0. All right. So if a is a constant and a is not equal to 0, and you have to differentiate this function, how do you go about it? That's what you are supposed to know. You can differentiate it without using the first principles. It means you have to use the short form or the shortcut. Yes, you have to use the shortcut form of differentiating a given function. So given this function, the derivative of this function will be dy dx is equal to, now when you have the power, so it's going to be in this form. We have the power here to be n. So this power will now multiply the power here, will come down and multiply the expression given. Then that same power here, you subtract 1 from it. So the power of the variable or the independent variable will be reduced by 1, and that same power will be used to multiply the term of that particular variable. All right, so it implies that our dy dx becomes n times a, then x, then we have our power here to be n, which was in the given function, then minus 1. So you just reduce the power by 1 and you multiply the given term by, this becomes a, sorry, this becomes n, then a x having a power of n reduced by 1 or decreased by 1. All right. So if you have a question in this form, if you have a question in this form, y is equal to 2x squared, and you have to differentiate. We have learned how to differentiate from the first principles. But suppose you are just differentiating without any restriction. You have to find the derivative or the gradient function of the curve without any restriction. The only thing you are supposed to do is that you apply the power rule. So this becomes dy dx will be equal to, then you have to identify the power. The power here is positive 2. So it's going to be 2 times what you have, the term in the function. So it's going to be 2 times 2, 2 times 2x. Then you have your 2, which is the power minus 1. So you can see that we still have our 2 here. This 2 is in the original function. So nothing has changed. And we have used this power to multiply it. So that is why we have the 2 here. That's why we have these 2. Alright. So this becomes our dy dx becomes 4x. Then we have here to be 2 minus 1 as the exponent. So it becomes 1. And which is the same as 4x. Alright. Let us take other examples and see what we can do. So we have y is equal to negative x, and you are to find dy dx or y prime. So using the power rule, our dy dx will be equal to the power of x here is 1. So you use the power which is 1 to multiply the original term in the function, then you reduce the power of the independent variable by 1. And this will give us negative x having a power of 0. And we know that any number except 0 raised to the power 0 is equal to 1. So we are going to get the result to be negative 1. We're going to get the result to be negative 1. Right, let's take other examples. Suppose we have, let me write it here. So if I have another one to be, let's say I have another function to be, if I have my function, that's question 3, I have my function to be p x having a power of negative 2, where p is a constant. So here our p is a constant. If we are to find y prime, which is the same as dy dx, now how do you go about it? You have to apply the power rule. So the power rule is going to be our dy dx will be equal to the original function. So the power of the original function, which is negative 2, to multiply the function p x negative having a power of negative. Today you are going to reduce the power of the independent variable by 1. So this will give us negative 2p x having a power of negative 3. Alright, so it's very simple. It's very simple. And I hope you really enjoyed this particular lesson. In the next video, we'll be looking at the other rules of differentiation. We'll be looking at the product rule. We'll be looking at the chain rule. We shall look at the quotient rule. Then the last thing will be how to differentiate implicit functions. So all the functions that you are dealing with are explicit functions. So there will be a video on how to differentiate given implicit functions. Thank you for watching, and do not forget to subscribe to my YouTube channel, Math with Ebefa. Bye.